Welcome to class 10 science. We will start new chapter 5, periodic classification of elements, and in this video we will discuss about what is classification, importance of classification, Döbereiner's triads, Newlands Law of Octaves. First, what is the meaning of classification? Grouping of various things of same properties together and segregate from others having different properties. This is called classification. Things having the same properties are placed at one place. Okay. You can also say the act of distributing things into classes or categories of the same type. You can also say classification involves putting things into a class or group according to particular characteristics. For example, in a shop, soaps are kept together at one place while biscuits are kept together elsewhere. Okay, you can see these are the some diagrams. In this, these soaps are at one place and these biscuits are at one place. Even among soaps, bathing soaps are stacked separately from washing soaps because bathing soaps have different properties, different characteristics from the washing soaps. They are also segregated or they are also grouped according to the brand name. Okay, you can say that is biscuits. This is the one type of biscuit at one place. This is the another type of biscuits at another place. In the same way, you can say this is one type of soap. This is all the soaps of one type are kept here, and this is again brand, this is the different brand name. Soaps are segregated. Okay. Then what is the importance of classifying things? Classification makes it easier to organize, to identify, to easily communicate with others, and to study. Why do we need to classify elements? In 1800, only 31 elements were known. By 1865, the number of identified elements had more than doubled to 63. At present, 118 elements are known, and it is very difficult to study individually the chemistry of all these elements and their innumerable compounds individually. To ease out this problem, classification of elements is necessary. First attempt made by Döbereiner, okay, and this is known as Döbereiner's triads or law of triads. Döbereiner showed that when the three elements in a triad were written in the order of increasing atomic masses, the atomic mass of the middle element was roughly the average of the atomic masses of the other two elements. This word triad can be used for the groups of three, not only elements, in general groups of three. It makes one triad. And Döbereiner's triads are like this. This is first triad is lithium, sodium, potassium. Second triad is chlorine, bromine, iodine. Third triad is calcium, strontium, and barium. Now, if we compare the atomic masses of these elements, then atomic mass of lithium is 7, sodium is 23, potassium is 39. And if we take the average of this 7 and 39, like this 39 plus 7 divided by 2, and this will come 23, which is the atomic mass of sodium. The same way, for chlorine, atomic mass is 35.5. For bromine, this is 80. For iodine, this is 127. And if we take the average of atomic mass of chlorine, this is 35.5, and iodine 127, then this will come 81.25, which is roughly near to 80. Another one is calcium, atomic mass is 40, strontium is 88, barium is 137. And if we take the average of atomic mass of calcium and barium, that is 40 plus 137 divided by 2, and this is equal to 88.5, which is near to 88. Limitation of Döbereiner's triads. Döbereiner could identify only three triads, which we have discussed. from the elements known at that time. Hence, the system of classification into triads was not found to be useful. Then another scientist, Newlands, that is, he gave Newlands Law of Octaves. He arranged the elements in the increasing order of their atomic weights. Actually, this weight word was used for the, nowadays we use the word mass. Okay, that is atomic mass and atomic weight is the same thing. In earlier, atomic mass was called as atomic weight. He arranged the elements in the increasing order of their atomic weights and noted that every eighth element had properties similar to the first element. The relationship was just like every eighth note that resembles the first in octaves of music. Okay, as we know, there are the 7 notes in music, and in Indian music, we can say this is sa, re, ga, ma, pa, de, ni. These are the 7 notes, and again 8th will repeat as sa. In the same way, if you compare the properties, like this is lithium, 8th element from lithium is, you can say this is 1, 2, 3, 4, 5, 6, 7 and 8. Sodium is there. The properties of sodium and lithium are same. In the same way, you can also compare, like this is carbon. The 8th element from carbon will come silicon. Properties of carbon and silicon is same. Limitations of Newlands Law of Octaves. It was applicable only up to calcium, as after calcium, every 8th element did not have properties similar to that of the first. It was assumed by Newlands that only 56 elements existed in nature and no more elements would be discovered in the future. In order to fit elements into his table, Newlands adjusted 2 elements in the same slot, but also put some unlike elements under the same note. You can see that cobalt and nickel are in the same slot, and these are placed in the same column as fluorine, chlorine and bromine, which have very different properties than these elements. You can see this is cobalt and nickel. These are placed along with the fluorine, chlorine and bromine, and the properties of cobalt and nickel are completely different from fluorine, chlorine and bromine. The same way, iron, which resembles cobalt and nickel in properties, has been placed far away from these elements. Again, you can observe this table. This is cobalt and nickel are here, and iron is here. The properties of iron is similar to the cobalt and nickel, but iron is placed far away from cobalt and nickel. With the discovery of noble gases, the law of octaves became irrelevant. Okay, student, subscribe my channel to get the new videos from this chapter. Thank you.